What is going on, guys? It's Bucky and welcome to your 31st tutorial. And in this tutorial I'm going to be talking about something that every single computer science student on earth just absolutely hates, and that is called recursion. Now this is a topic that's somewhat confusing, but I'm going to try to make it really simple for you guys. So what recursion is the idea that a function can call itself. Pretty weird, huh? So you know how like in main we could call another function called Bucky and Bucky would print something out on the screen? Well, recursion is the idea that Bucky could call Bucky. That's interesting. So let's go ahead and take a look at this right now. Say we had a function called Bucky, and all it did was print something out on the screen like cout. Let's print out something stupid. OMG, WTF, BBQ. Oh my god, WTF, barbecue. And then it went ahead and it called the function again. So now you'd say, alright, well, isn't this function gonna go ahead and we're gonna run main first, and main's gonna say, okay, go ahead and run Bucky, and Bucky's gonna say, okay, print this out and then run Bucky. Okay, Bucky, print this out and then run Bucky again. Print this out, run Bucky. Print it out, run Bucky. And whenever we go ahead and run it, we can see that this is a function that basically never ends. It prints out, oh my god, WTF barbecue, until, check it out, watermelon exe. My computer just crashed and gave up on this. So I'm like, alright, so what's the point of using recursive functions other than don't use them? Because, first of all, if you build a recursive function like this, your computer is going to crash just like mine has, and it's not the most useful way to go about things. So one reason that people use recursive functions is, first of all, let me mention this. Whenever you build a truly perfect recursive function, you need to have something called a base case. Now, a base case is pretty much an ending point for your function. So one example that I'm going to be showing you guys is how to calculate factorials. Now, if you remember from math class, factorials are pretty much when you say 5 factorial, and it's written like this, 5 exclamation point. This is pretty much the same as saying 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Whatever factorial it is just whatever number times all the way to 1. So then the value of like 5 factorial is 120. The value of 3 factorial is 3 times 2 times 1, which is 6. So let's go ahead and write a program to do that, and this is one of the instances where recursion is actually a good idea. So let's go ahead and make a function called, we'll call it factorial find. So int, first of all, better spell that right, int factorial finder, I think I spelled that right, and it's going to take a parameter which is int x. Can I not spell int today? Int x. And the parameter it takes is what value do we want to find the factorial of. So if we passed it in 5, hopefully it would give us 120. If we passed it in 3, it would give us 6, so on and so forth. So the first thing we need to build is something called a base case. Without a base case, this factorial finder would never end. Just like Bucky, you know how it ran forever until my computer crashed? This is what this is going to do if we don't give it a base case. So we need to say, okay, if x is indeed equal to 1, then we want to go ahead and return 1. So whenever you return something, remember your function ends, and that's the point that we're trying to get to. So in order to do this, we're going to assume that they're going to be passing in numbers other than 1. So we're going to go ahead and do this. Else, if they pass in a number aside from 1, like 5 or 3 or 20 or something like that, go ahead and return the value of x, which is, 5, 3, 20, and then go ahead and multiply that by factorial finder x minus 1. So what it's going to do is, yeah, it's going to call the same function again, but it's going to call it with a different value. It's going to call it with 1 less than before. So if you go ahead and you pass in 5 to this function, what it's going to do is say, alright, I'm going to call 5 times the 4 factorial, or factorial 4. I don't even know how to say it. I'm not a mathematician. But anyways, what it's going to do is it's going to say this. I'm going to call 5 factorial 4. Well, what's the value of that? I don't know. The value of that is 4 factorial 3. What's the value of that? I don't know. 3 factorial 2. What's the value of that? I don't know. 2 factorial 1. What's the value of that? I don't know. Oh, wait, I do know. 1 factorial is 1. So now that it has that bit of information, it can go ahead and solve the rest of the questions that it asked. You know how I said, I don't know, I don't know. Well, now it can say, alright, Bucky, 1 factorial is 1, so now I know that 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and 5 factorial is 120. So that way, you can see that whenever we go ahead and run this, factorial finder, there we go, I didn't feel like printing out the whole thing. That way, when you print out factorial finder 5, and let me just go ahead and end that line, and we run this program, it says 120. Yeah, it was 120, but there is a lot of stuff going on behind the scenes that the user didn't have to see. What it did is said, alright, it ran this function like 5 different times searching for 5 factorial, and then it called it again searching for 4 factorial, then did again searching for 3, 2, and finally when it got to 1, it could answer all the rest of those questions. So this is how you can use recursive functions in a useful way. Again, a recursive function is just using the function inside the function body itself. And remember, whenever you do this, you need to have a base case. You need to have an ending point that actually answers that question. So in this case, whenever they got to 1, it could solve the rest of its questions, because if we didn't have that base case, like before when we printed out OMG WTF barbecue, it would just run forever and ever and ever without an end. So that's why you need to give it a base case, in other words, a point to get to, where if it solves that question, then all the rest of the questions can be solved. So again, you guys can probably see why people hate recursive functions, but why sometimes you actually need it, because there's a lot of stuff going on behind the scenes that we don't get to look at, but we just have to, assume in theory that this is going to work. So it's a little bit different than regular programming in the fact that you don't explicitly call a function like this, that a function is going to call a function for you however many times it needs to. So there's a lot of theoretical programming that you need to think of, and a lot of different things that can go wrong with recursive functions. So that's why I wanted to show you guys a quick example of the bad way to use recursive functions and the useful way to use recursive functions. But now that I taught you guys that tutorial, we can finally, get over recursive functions. You will be happy to know that I don't use recursive functions a lot in programming, and we're probably going to be, done dealing with them for a while. But, it was a topic that we definitely couldn't skip, and now that you watched this tutorial, I'm glad I taught it to you guys. So thank you guys for watching. Don't forget to subscribe, and don't forget to put a base case in your recursive functions, or else your guys' computer is going to crash. So thank you guys. Don't forget to subscribe, and I'll see you in the next video.